Okay, guys, here's a guy out of up above Pittsburgh. We'll give a shout out to him. He says concrete with the horses. All right, that's how he says his channel. He does some really nice stamped concrete borders, exposed concrete is what he really likes doing. I enjoy looking at his stamps and his the work. I enjoy looking at the work. All right, it's probably only one guy I probably don't enjoy much. The one out of up in Illinois or somewhere like that, with the big obese guy that just barely pull up the wire and barely talks. That guy, that channel there, that work, I'd waste my time giving advice I'm about to give to Concrete with the Horses. Now this goes out to my man also out of Grub Mud. So Grub, this is you too. I said I would make something like this for you also. Well, I can do it for Hoss here also. Let's look at my comments and let's critique myself even. Okay, I wrote, nice to see you using fiberglass. I saw him using fiberglass in this video. He scraped off some cream. I saw the fiberglass in it. He didn't say he was using it, I don't think. But I saw it. I would like to see those half-inch tool joints with perhaps a follow-up half-inch deep saw cut, meaning a total of 1 inch at least. So he's doing these joints. They look about a half-inch of profile. Okay. So after you set them, you come back and cut another inch. And say you've got 3.5 inches here, which typically is not really 4. It's typically 3.5. That will leave dimensionally on the rest of the concrete. It's not as stable. More of the concrete over here, more stable than this dimensionally changed system there. The interesting, that's more for loading. That's going to be for another video. It's not for expansion and contraction. A lot of people call it control joints, things like that. Not really. I'll explain that in future videos. And the short version is, you're still got butted concrete there. You have to put a full joint through a full separation for this to work. When I say full, you could argue back, well, I did 9/10. Yeah, well, you're right. That 1/10 really won't matter. All right, so it leaves some tooling. Okay, let's look at my comments. Okay, so I state 6x6 wire mesh is what it's typically called. It's welded wire fabric. Is the welded wire fabric, WWF. But typically contractors call it wire mesh. All right, 6x6 is one of the size, 6 inches by 6 inches. I'm going to show you that in a video in a moment, how awesome this product is. Okay. Let's see. Hint. If tool joints create a control joint, what would rebar do? So in other words, if your tooling joint, this tooling joint here, creates a control joint, well, what happens when you have concrete here and you put rebar in it? What is that creating? It's an internal control joint also that you're creating with these voids you're creating, but you're filling the voids with steel. But then it needs bond strength, right? So you're changing the behavior of the concrete and the steel will not be one and the same. Concrete over here is one and the same. When you put the wire in it, it's going to be different behavior. And when you put rebar in, a different behavior. This is so small. These 3.5 inch pads that, you know, it's overkill using the reinforcement. And a lot of times I see contractors, and I think, Hoss, you might be a 2 Hoss, put the reinforcement going this way. So yeah, it's think of rebar. You know, it's a longer reply video, and I don't want to go down that line, but think of it like a beam at that point. So you've just created a beam on the edge, but only with loading coming in this direction or this direction. You didn't do anything for the center here. It does not do anything worth value. Okay, so Why? Okay, I'm busy. I promised you a video. I said that before to him, so now I'm getting to it. I always enjoy your exposed concrete. Hope you stay a good sport, meaning me doing these type of video, my comments rather. Wait, are you using GoPro? That's what I want to know about that. I didn't answer it because it sounds really good. Not sure why you're saying the rebar and wire are not suitable. Looking forward to Looking forward to your video whenever you make it. So the rebar, just wire mesh. All right. So I want you to see this wire mesh. All right, Grub Mud. I want you to see this too. Okay. So I'm going to show you another video I made on this, but I want you to visualize that. Now this is working two directions. This is two-directional reinforcement for loading any direction. I don't want to, I like Columbo moves. I like giving hints, but let's do let's do this, and I'll go to that video too. This is just a wall holding a slab sticking out. There's nothing here. This is just air. Okay, air. All right, so air ball, and here's a reinforcement at the top. If I were to push down on this end here, load here, you can see it would elongate here. Okay. Now let's put the rebar at the bottom. Let's put the load here. You can see that this would break free here, and allow flexing to go down. So Haas, when you're doing the borders, and frankly, when you're doing your cars, also where your cars are, your borders. Dropping something. Sorry. That you want to think of that loading and put and Grub. This is what I was going to tell you. I was going to do for you and for everyone. Put it top and bottom, but top or at the edge. All right. So let's look at this profile. So let's look at the concrete, and this is the car here, wheels here, wheels here. Okay, so here's loading, and let's do the forces kind of like that. Okay, so your rebar is at the bottom, where everyone's putting it. And it's not helping for the right here where the loads want to fracture off, rotating this top edge, this edge here off. But if you have rebar at the top, near the edge of the driveways, you don't have to put it inbound too much. You can step it. You can do that to mat it that way. But but this is just for the edge, because in the middle where your car loads, like this tire, if it loads only in the middle, you want that rebar in the middle. If it gets near the edge, I like to see you put rebar at the bottom and a mat near the top. All right, so let's change colors. So a mat near the top and the bottom the bottom continuous, but as you're edging, and this is the wire mesh. Put the mat there, and I'll show you. I'll show you. But with your separation, your stresses, if I would just clear this up for a second. Let's clear this, and let's do it again. So here's your car, and we know cars driving on the edge, so I know the tire we're looking at that way instead of like this, right? Let's just do that then, so I don't trigger anybody. So they parked on the edge to let other people pull in. Well, you can see what happens there when they parked on the edge of the driveway is that this wants to fracture off like that. And your rebar down here is not helping. But rebar at the top would take in that tension of this wanting to drive down. So that's why at the edge there. But at the middle of the driveway, all bottom rebars perfectly well, and then that's your edge. So Haas does borders, beautiful borders. So I'm going to compliment him on that. So he does these borders, but frequently Haas does the border secondary because he'll do exposed. Maybe he did in this one. I don't recall. But here's his main driveway. He'll do that. And maybe this will be exposed, and maybe this will be added later. These two reds are added. And I've seen you put your concrete down here. I feel like I'm talking to Haas from the Cowboy Show. All right, Haas, you can see that your rotation, if they drive on top of that edge, is loading down. It's just going to break free. But if you put your rebar, put it at top and bottom. But here's your top. Now tie it back here. Pretty good, your wire mesh. Or if you want to dowel it, but I'd rather see that wire mesh sticking out. And now this will bond. Now let's prove that proof of concept. I'm going to show you this fully broken and one of my videos I've done, and then we're going to show you how badass wire mesh is. Welded wire fabric, wire mesh, however you like. So be a good sport, Hoss, and Grub, you are already a good sport. So Grub, you gonna grub mud. You follow Hoss, Hoss follow Grub, and help him out if you can. Hoss, he's doing it. He needs a little hand. Give him a little pat on the back. All right, there shouldn't be any hate here with competition. I like photography. In photography, there's nothing but jealousy in photography. All right, there's just one jealous person after another. There's no pat on the backs. And in engineering, there's usually no pat on the back. All right, there's usually trying to find defects. And contracting, there's often pats on the back. Man, you did an excellent job. That's badass. Awesome, awesome. Well, let's keep it that way. All right, let's keep it that way. Let's. Let me show you guys some of Hoss's work here. Let me see if I can speed it up a little bit. All right, steps, driveway. I'm not going to nitpick on anything like that. Border.
That's good.
Okay, Hoss, so let me blow this out here. And there's your border and your reinforcement. This is Hoss's reinforcement here. And that one bar there, that helps in the deflection loading, and depending where it is, high or low. If it's in the neutral axis, you basically bid nothing. So if you do it in the middle, you really change your strength. There's somewhere probably about there, right, just a touch below it. So if this was, say this was 6 inches, you've got it down to maybe 4 now by doing that. Now the car will drive up here, and so that will help with that deflection and that capacity. It's bending, but in this capacity, it just wants to fall over. It has to just fall over, as I'll show you in a moment. Get it? It's a moment. He's going to tool that joint. It's a full joint all the way through. The rebar, the doweling is going to help hold this together. Don't think of the dowels, and I did a video and I didn't post it. Don't think of dowels as, I want you to grab 2 pens. I want this to be a pen here and a pen here. And you butt those 2 pens together. And when you butt them together, now put a load here. And you see what happens. They just pull right apart, right? Now I want you to overlap your pens, your ink pen. All right, your pens. About a little bit. And then you'll see a little bit better. And then I want you to overlap it a little bit more. And then a little bit more till you realize, oh, you know what? If I overlap it by, say, half a pen, I really get some transfer from here to here. This becomes acting as one. And that's what you're looking for there. Now, dowels, a lot of people do it thinking it's just going to stop it from just bending, breaking, going downwards. I don't want you to think of that unless you do rebar pull-out test and you epoxy those in. If they're not epoxied in and you didn't put it near the top because this is an overhang, if you didn't put it near the top, and I'd like to see some bottom action in there too, please. If you didn't put it top and bottom and epoxied, passing the rebar test, not doing a pull-out test, and you didn't epoxy it, you're jamming it into a tight hole, and you're calling that friction ability to hold the car is incorrect. All right, so let's look how pretty this might be when Hoss is done with it. He did a stamp. Yeah, see that? Roll stamp. Now, this is a cut joint, which I really like. Cut joints. Saw cut. That's nice. Too bad you can't. It'll look like a mess if you don't seal this. But he is in a climate, Pittsburgh, where Sikaflex would be nice in there. Sikaflex product to seal it. You don't want water getting under the pad. Yeah, it can come through the sides there a little bit, but so be it.
So we wanted the border a little bit longer than my stamps.
Okay, so you can see the beautiful exposed concrete there. He likes using a release and then spraying it off. Yes, you'll see it on the garage doors and stuff like that, but I'm sure that he comes back and removes it off the garage doors. So yeah, you can pick a little. We can pick at each other's work or people's work all day long. He's doing it. Let's go. So when it comes to my video here, title, whatever the heck is the title, concrete action at wall explained. Not vertical shear failure. Okay, so vertical shear just means that imagine if you can just load something literally just vertically without putting a reaction, a torque on it. And the torque, if you press down on this piece of wood here I have here, the torque, if you press on this end, it would create a pushing effect against the wall and a pulling effect at the top there. Imagine with nothing holding it on there, what would happen if you could brace it. Now, if you could just push it straight down, you would just be shearing, the pure shear, just straight down. I'm going to go over that in this little video here, and then we'll help explain that. Haas and also Grubb, and anyone else, contractor, concrete guys, I want you to think of the of this as what we saw Haas do, the extra slab, the extra piece near the edge. Or I could care less. Think of it as your driveway, and this is where the car's tires load also. So I want you to think of this outside edge as independent reaction, then your field, your center part of your driveway. Let's look at the driveway, all right? Here's a tire here. Here's a tire here. All right, all the rebar in the middle is okay there. All right, you got, significant distance here. I'm counting significant distance, 3-4 feet. All right, it's stressing the rebar in that capacity. When you start getting near the edge over here with your tires, now it changes. Now it changes, and now you start seeing cracks. See that little, see my low path? Now you start seeing these cracks near the edges. And when you come up to a driveway, you see the cracks on the edge, or crack, the car was too far over, or over here. I'm sorry, I should be more clear. This would be probably more in line with that crack. Let me do that. So there's your pattern. You'll see that you'll be able to affirm this if it's the crack. If you look at it and it appears to be open. So when you look at there, you look down from the top and it appears to be open, not compressive, not compressed. If it is compressed, then what you have now is your middle pad, your center of your pad is sinking. This pad is sinking, all right, it's sagging, and the reaction is resolving itself. Well, it will probably be a fracture at the bottom if you have rebar. And thinking of the load, wherever your tires are, you'll have that fracture there. And you'll see it compressed because in that crack, you'll see spalled concrete out of the crack. It'll be like it's chipped off. And that's because of the compression effect of it and the pad bending, if you will. Now let's let this clown play. That's me. And let me explain to you.
One more time to this.
So I put a piece of rebar through here. I want you at Grubb and Haas to think, and all the other contractors, concrete guys, to think of this as the rebar at the top. All right? I'm going to spin this board around, then you'll see the rebar at the bottom, and you'll see the difference.
This is some material wood that I took apart for you guys. There's a rod.
On the backside, you see that's how I anchored it through to secure it. There's a thread all going all thread going all the way through. All right, it's bolted right about there somewhere.
It goes through.
Not bolted enough where I can't rotate it. Not that taut.
And it's acting as top rebar reinforcement. I'm going to spin this sideways to show you there's nothing else there besides that.
Now imagine
top bar.
Now imagine how thin if you had your concrete like that in the middle. The rebar's in the middle now. Watch how easy this flexes.
And I'm also going to show you how this deflects.
Nothing, right? Nothing.
When it's narrow, when it's thin like that.
See?
Like a springy board.
Like a damn.
Right now, let's go ahead and turn it, spin it.
And now
it's like a deck.
All right. So once you think of this as now, even though there's no rebar at the bottom, you can imagine now when you push down that end, it has to push against this end. The force multiplier effect of that rebar at the top and the redirect.
And let's go ahead and consider this a 9.5 inch deck, if you like.
Concrete deck.
Okay, so now look what happens when I lift up on this end down here. Oh, of course it would, right? Of course it would. It would lift up.
So that would be a bending moment I talked to you about if you had a sagging deck, a sagging pad that it wasn't compressed, that you didn't compact the soil tight enough to make the beam, if you will, act as one. I want you to think the floor is a beam, especially that edge over there, Hoss. Think of it as a beam, and you want it to not dive down, to not dip. So make that thing tight, that soil around there, tight.
At the bottom. But what happens when I put a load here, though? Called sagging here, if you will. What's going to happen down that end? It's going to
My load?
what? Brace itself down there. It's going to put this in tension, this top steel in tension, and brace itself at the end. So that's pretty darn nice, isn't it?
It's simple as that, guys.
And so much so it'll move this. Now this gets kind of sloppy. Could get a little tighter. But it's now pushing. I mean, it's really pulling on this and pushing back on the wall.
Top rebar, okay? Put this top
Pushing
wire
back on the
there.
wall as I load it down here.
Video, I'm gonna jump
Now
to.
let's come up here and just create an elevator drop, a shear action just going straight down. As if no deflection would happen out here. It just happens to just want to go straight down. Is it even possible? Well, look how loose it is. If I can grab it, lift up,
It should be like your down.
and then push
if you
down.
could
Lift
do
up,
that.
push down. Well, I'm at the bar. The bar is right about here somewhere.
This is your
So if I
down.
keep pushing down, it's going to splinter this off, right? It's going to spall it off.
Let me see if I spin
But
it
if I
upside
push down here, it's just putting this steel, as you can see,
I just
down on this side. It's rotating out. Can't rotate out because at the back end, that rotation loops like that, right? And that means coming back and pushing against on the...
You know what? You'll know the. You have the title of this video. Let me give it to you again, and then I'll show. That's what title is called. This one right here, right? This title. You can find it. Now I have one more video to tie this to, and then you'll understand why wire is so beautiful. So this is another one of my videos you can come to called Concrete Repairs. Placement of rebar in concrete. Doesn't matter about rebar at bottom or a pad, all right? Rebar is reinforcement. I don't mean the rods, all right? I'm just talking about reinforcement. So that's that title. Okay, so in that video, this video, I take this slab. I first show you a crack. It's about 13 minutes long before you get to the next stage of the video. But it's just showing you how cracks develop, all right? So you can come here and torture yourself for 13 minutes. Or let me just scrub here for you. So
that was the rotational side.
And I'll show you exactly where the fracture is. It's exactly predictable. You know, that's where the cracks are. Now here I grab another piece of slab that I'm able to get a fracture out of. And I use a machine to lift up the slab. And I drop it until I fracture it fully. This is worthy of your time. Both you, any contractor, worthy.
Watch it again.
On why you don't have to get also so crazy about your rebar that might be on the bottom. I'm not saying do that. Bring it up. Give it some cover to protect it. But I'm saying the engagement is what matters. And I'll show you. Wait a minute. I guess I should back this up. Right there. So there is the reinforcement. It is on the bottom. I mean, you guys can see this is like exposed. It's bottom. I mean, they didn't. This is over 40 years old, this piece. And they didn't go, they did not, it's a commercial job it came out of. They did not care that it was on the bottom, all right? Or maybe they did, and then they walked on it and they went to the bottom. Because frankly, I see people lift rebar up all the time, then they step on the, workers step on the concrete. Yeah, you know that you're not floating on top of concrete. I hope you know that, guys. You're just pushing that rebar back to the bottom. If it's not on chairs, you're just pushing. If you don't feel springy and like you're walking on springy rebar, yeah, you just push the rebar down to the bottom. So let's get
Over the stone. The stone has more tension, was able to resist this.
There's another section.
Exactly where.
Let's back it up just a hair. So you can see it's very little cover. Very little cover. The rebar is really in great condition. The reinforcement. The wire mesh. All right, welded wire fabric.
Nothing there. But that rebar, let's call it the rebar, the pipe.
So I'm going to turn that down, and I'm going to narrate over it. So there's the fracture. I'm going to lift this up, and and there's wire back there. All right, there's wire in the back of this. There's wire here, but there's no wire over here. So I just turned the slab upside down. So this will be the finished part, and that's the bottom section we're looking at. And I just lift it up until I bring it to failure, where it just bends over like it's nothing. Where I flex it. Okay, so I'm going to have this flexing in two directions, obviously. This direction and here. And this will be it's fully open. You'll see I won't, there we go. Come on. You see it fracturing. And here comes me jumping on it, I believe. So you can come back and watch the video if you want to hear me talk. There's no bottom reinforcement this time, but that's the top part. All right, so it's totally shot, right? What can you do with this? You can just throw this in the trash now, right? It's junk. All right, that's what you think it is. Let's fast forward. And there it is here, just totally broken apart. You can see it's just two sections. There's the raggedy rebar, if you will. You can see the mapping of the rebar, the reinforcement, the mesh, wire mesh. And it's just totally open, right? Totally junk. And I just throw it back down. Oh, there it is. So this is what it looks like now. It's just fully broken through. There's just wire on the bottom. That's the top surface we're looking at now. I'll bring the machine over. I lift it up. And I stand on it. I talked to you about the reinforcement. What I don't talk to you about in this video is what's needed. This needs to be epoxied in, but I didn't want to get too deep for you guys on that. I need to be epoxy in if you're coming across to this problem. Grouted in, epoxy, preferable. A little more in depth, but now let's go ahead and let's show you this right there. So, yep, cue up. There we go. You can see it's totally down to just the wire. Get it? It's down to the wire. Right here and here. That's it. It's down to the wire. There's your concrete. There's your concrete fully separated. So what can you do with it, right? Watch.
It's just down to what, one piece there, two pieces?
Now I'm going to fast forward it.
So
I'm going to put it on top of this guy here. It's elevated. I'm going to drop it down. Wait a minute. Drop it down. I got to fix that real quickly. Again, there we go. So no magic act. You can come to the video. The title's at the top there. See, I'm going to press it again, and there's the title. And now I'm going to load this with the machine. You see the machine is only on its heels. And the other contact point is here. And this is flat. And yet, these are two pieces of concrete, aren't they? Two pieces. It's the bottom reinforcement that's holding this together. It's on the bottom. Now, also, I'll tell you in this one then, imagine this was V-shaped. Well, this would just fold over. So the stresses are inside where this concrete is butting now. The stresses are there. There is no ifs, ands, or buts about it. The metal can't stretch, so this puts this in compression around about that V shape, around like that. Now I'm going to load it right there at the seam. I'm going to lift the machine up there. There we go. Now it's got good clearance. You can see its clearance under there. It's back on its heel, and the next point is here. As I talked about, you have to put a scale on it to figure out what's going on. But if you want to know how much loading,
so if we had a scale, we'd be able to tell you how much
it's not touching. We saw that a second ago.
Across the blade, but I could point load this even more if I had a.
And there we go. Oh. Well, that was interesting. It jumped me to a new video. You can see it's not touching. I'm trying to see if I can. There we go. So you can see the clearance is there. It's not touching. But when I look at it from the top, when I bring the camera in, it looks like it is touching, but it's not. Like right now, it looks like it's touching. So it's not. And now your load point is distributed across that cable across this steel plate. And I could use a weight to determine that, but nevertheless, you saw it's two sections. So let's pause it here. And now I want you to think Hoss and Grubhub Mud. Your rebar at the bottom now. Right? Your rebar at the bottom. This is over here though. Remember, I've got something here holding it, so it's a little different. You wouldn't have that there. It would just be soil. If I were to put soil here, let's say this is all soil, right? And we start getting erosion here. We get erosion because of, it's by the edge of the sidewalk. It's by the edge. Here's the soil out here, all right? And it starts eroding, undermining our pad. All right, it's going to happen as they hit this section here with their vehicle. It's going to create a bending moment here, so it's going to be reversed because you're not getting any strength down there from the bottom of this. Now this is not really helping you. The bottom rebar is not helping you. But if you were to put top rebar there, top reinforcement and wire mesh, I'm happy with. And you would come into there like that. So bottom reinforcement also, and top mesh. And then bottom all the way across, and then top mesh near your edges. Now you're going to cover it when they load here with their tires. It's now going to try to flex this section of slab over, but the reinforcement will grab it from the top. If you try to grab it from the bottom, you're going to go nowhere. You're going to get this. Remember, I flipped this over. You'd have to invert that in your brain. So hold on. Let's see if I can do better than that. I'm looking at the thumbnails. Yeah, I can't do better than that. So you can imagine, though, if this was supported under soil and this whole edge was not, even though bottom reinforcement's there, you know what happens if this can stay, if this stays supported, this will just flap down. But when you reverse it and put it up there, now it's supported. It's pulling back on the counterweight, the counter anchorage of the pad. Hope this is understandable. Go back to the video part where I show that piece of wood where you flip it over and you can see it. Imagine if it's flipped over the other side and you would understand it. Well, this is what it looks like in real life. And this is my sample life. This is what you can make this yourself to help you understand it. Just grab a piece of wood, put it all thread through it, and then do this and flip it over upside down. And you'll see that, all right, down the bottom, load it there to where my left hand is, loading down. It's going to be in tension at the top. But if I only had rebar at the bottom, it would just separate. It would separate the top right here. But since I have rebar there, it works, and it push counter forces here, right? All right, I hope this was helpful. But again, remember, if I turn it upside down, it's just going to fracture. Let me get you a little different view. Foghorn outside. Interesting.
On this and pushing back on the wall. Pushing back on the wall as I load it down here. Now let's come up here and just create an elevator drop, a shear action, just going straight.
I'm scrubbing
down,
at the bottom there.
as if no deflection would happen out here. It just happens to just want to go straight down. Is it even possible? Well, look how loose it is. If I can grab it, lift up.
Yeah, come to this video and just learn from it.
Well, I'm at the bar. The bar is right about here.
Learn from it.
Just in tension.
And you'll understand why this is working. That my foot is plowing a downward force and it's being captured by the reinforcement at the top. Imagine if the rebar was at the bottom only, and now put the force out here such as a car, a surging of the brakes, stopping, and you have no top reinforcement. It now wants to open this up, right? It would open it up, and in reality, it'd probably look more like the stresses would probably look more like that. And between these two is where the fracture would probably develop, right there. It wouldn't be like this. Now it sure would be in Haas's case, since he does 2 different pads a lot. He does this. His reaction. Yep. So that was brilliant. Okay, so this is the edges Haas, and here's your main pad, your car pad, and then let's do the reinforcement at the bottom. That was terrible color. And let's do the reinforcement at the bottom. You can see that loading here can easily cause this section to open up. Additional wire mesh just laid across. Difficulty doing, yes, so that's why you see it often it's doweled, it's epoxied in. And you can buy those tips, Haas. You can buy multiple tips on eBay and use one, 15-minute setting epoxy, fast setting epoxy. You drill all your holes, clean them out. You scale down your reinforcement to 1/4 inch, 3/8, 1/4 inch. I don't know what vehicles you're putting on, what vehicles they would be putting in, but I like it scaled down because I don't like the idea of water penetrating to that reinforcement, swelling up and then spalling off your beautiful work down here. So we want it to work, but we just want it not to separate. Now, of course, if this soil is so tight under here, I mean, if you make it so tight where water, of course, it's not possible, wouldn't penetrate it, then you no harm, no foul. It can't sink if it can't sink, right? It can't lower itself. It can't displace itself if it can't displace itself. But that's not possible. We know water will roll off this pad. We know water will get under there. We know freeze-thaw cycle of the soil around it will affect this. I don't want to drive you crazy, but you could probably drive a bunch of rebar pipes in the ground. That's another system altogether. It worked in Europe on a bridge. It was beautiful. Very complicated system, but simplicity in itself. Rebar, reinforcement. Take care. Love you all. Again, for my man who does mostly pads without the extra work there. So that's my man Grub. Then I recommend you just, let's give you a quick detail, Grub. So Grub just does pads only, pretty much. Grub, run your wire mesh all the way over. And then the edge of your pads where cars are you going, lay a next mat. Lay a mat here. Lay 2 layers of mats. And maybe come in, you can probably cut that wire mesh. Nah. Just lay the mat out. Just lay the mat all the way down the top there. Love fiberglass. But this is top mesh and bottom mesh. And run your mesh all the way over. All the way over. Just it's no issue. Stuff's so easy to do. Overlap your mesh. Remember your pencil, the rule I told you about. Depending on where you're going to cut your rebar, where you're going to do your saw cuts, it does matter. That's a longer video, and take care. Love you guys. Bye.